Happy Monday. So you should have taken the test, and this is just going over those questions. So question one, with a census, we take data from every individual in the population. So that's hopefully easy, just vocab. Um, Next one. Oops. So then you want to select a simple random sample of 50 students of the 816 who will live in the dormitory. You label from 001 to 816 in alphabetical order. In the table of random digits, read the following entries. So, and then what 3 labels. So I also like to do a process of elimination on these. So like I know this is my range, 809 to um, 809 to 001 to 816. So I know anything over that's out. That's 929 is out. And then this one is out. And then remember, we can't have doubles, so this is out. So then I still have to go through my random digits table. So 995 out, 929 out, 400 is our first number, so that's the correct answer. A study of treatments for angina, pain due to low blood supply to the heart, compared bypass surgery, angioplasty, and use of medication. The study looks at the medical records of 1,000 patients with angina whose doctor had chosen one of these treatments. It found the average survival time of patients given the medication was highest. What do you conclude? So, first of all, some things to think about. It says that the study looked at medical records of thousands of patients whose doctors had chosen one of those treatments. So there's no random assignment. So that's a key. The study does not prove anything because there was no random assignment. So, and without that random assignment, remember the key with random assignment is it creates roughly equivalent groups. So it would be A, for the first one, we can't conclude that medication prolongs life because the groups might differ, meaning there might be other confounding variables. Oops, I thought I crossed that one out. So that one was out. The reason it's not, I would call this D, we can't conclude the medication prolong life because the patients are volunteers. No, in experiments, oftentimes you use volunteers. It's just there should have been random assignment. We can't conclude the medication prolong life because no placebo is used. You don't always have to have a placebo. So they were trying to compare which has the better survival rate, the surgery, the angioplasty, or the medication. So in this case, a placebo wasn't needed. All right. How much vitamin C does orange juice contain? A nutrition magazine measures the amount of vitamin C in 50 randomly selected half-gallon containers of a popular brand of orange juice from 10 different grocery stores and concludes that the containers produced by this company do not have as much vitamin C as advertised. Identify the population. So those 50 randomly selected are coming from 10 different grocery stores. So it would be, and it's important, these are half-gallon containers. So it is not all grocery stores, because then we would have had full samples from all grocery stores. All half gallons. Nope, it is not all half gallons, because once again, we did not sample from every. all half-gallon containers of this brand of orange juice at the 10 stores. Right there is what we're looking for. So we're looking at the half-gallon containers. It did say a popular brand, so from this brand, and then they were selected at those 10 stores. All right. Consider an experiment to investigate the effectiveness of insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for random assignment? That comes back to what is the best reason for random assignment? Brand A, brand B, brand C to the experimental units so far. Random assignment eliminates the effects of other variables such as soil fertility. So I'm gonna like put a star, like a little mark. That's possible. Random assignment eliminates chance variation in the responses. Potentially. So this is just kind of like how I'm thinking through. Random assignment helps avoid bias due to placebo. No. Now, the placebo effect comes in when you have subjects. These are plants. There's no placebo effect. Random assignment allows researchers to generalize conclusions about the effectiveness of the insecticides to all farms. Like maybe that does sound like a possibility. Random assignment will tend to average out all other controlled factors such as soil fertility so that they are not confounded with the treatment effects. So that one to me sounds like the best one. Random assignment helps just avoid those confounding variables. And it's more than just the soil fertility, but anything, because it creates those roughly equivalent groups. Researchers randomly select 17,000 people, 1,700 people from Canada and rated the happiness of each person. 10 years later, the researchers followed up with each person and found that people who were initially rated as happy were less likely to have a heart problem. Which of the following is the appropriate conclusion? So remember, this is just a study, so we can't say cause and effect. So anything with causes is out. Okay. So happier people in the study were less likely to have heart problems. Happier people in Canada are less likely to have heart problems. So we can make a generalization about the population. So we're randomly selecting 1,700 people from Canada, so we can say those people from Canada. The sales force for publishing company is constantly on the road trying to sell books. As a result, each salesperson accumulates many travel-related expenses that they charge to the company-issued credit card. To prevent fraud, management hires an outside company to audit a sample of these expenses. For each salesperson, the auditor prints out the credit card statement for the entire year, randomly chooses one of the first 20 expenses to examine, then examines every 20th after. So key there, every 20th, automatically, I'm thinking that's a systematic, which it is. So, bias in a sampling method is, so this is just another vocab, so let's go through. Any difference between the estimate from the sample and the truth about the population due to practical difficulties, such as contacting the subjects selected. I'm a little questioning that word subjects, but we'll see. Any difference between the estimate from an initial sample and the estimate of the second sample? That has nothing to do with bias. There's no initial and second, not bias. The difference between the estimate from a sample and the truth about the population due to using chance to select a sample, like maybe that's a possibility. Any difference between the estimate from a sample and truth about the population? I feel like there's something missing there. So I'm gonna like put a little mark, like maybe, but I don't think so. any difference between the estimate from a sample and the truth about the population, and here's the key, that tends to occur in the same direction whenever you use the sampling method. So that is bias. So it's this consistent pattern regardless of how many times you do the sample. There's always going to be that bias. You wonder if TV ads are more effective when they are longer or repeated more often, or both. So you design an experiment. I'm going to kind of skim over that. You ask all subjects how likely they are to buy the camera. Which of the following best describes this experiment? So we have 30, 60-second ads. The subjects all watch the same TV program, but you randomly assign them to 4 groups. One group sees the 30-second, one group sees the 60, and so on. Now, be careful. When it says groups there, really that was the 4 groups for treatment. That is not blocking. So this is just a completely randomized design. So it's not blocking, it's not match pairs. Now, is there 1, 2, or 4 explanatory variables? We're looking at how, if they're longer or repeated more. So those are our 2 variables. So can texting make you healthier? Researchers randomly assigned 700 Australian adults to receive either usual healthcare or usual healthcare plus automated text messages with positive message such as walking is cheap. It can be done almost anywhere. All you need are comfortable shoes and clothing. The group that received the text messages showed statistically significant, so I can see where this question is going, increase in physical activity. What is the meaning of statistically significant? The difference in physical activity for the 2 groups is very large. No, it's more than that. The result of this study should be generalized to all people. No, that always just comes back to randomization. The difference in physical activity for the 2 groups is larger than the difference that could be expected to happen by chance alone. That's the key. Larger than expected to happen by chance. So, elephants sometimes damage trees in Africa. It turns out that elephants dislike bees. So this is modeling like an FRQ, but it's setting it up in a multiple choice format. So just a heads up. They recognize beehives in areas where they are common and avoid them. Can this information be used to keep elephants away from trees? So identify the experimental units. So in this case, we are experimenting on the trees. There are 72 acacia trees. So not the elephants. The elephants are just what's helping us. We're measuring the damage they did. Explain why it is beneficial to include some trees that have no hives. So including, I'm automatically thinking like that's a control group. So including some trees that have no hives broadens the scope of inference. No, it doesn't. Inference comes from how was the experiment designed. The trees with no hives provide a baseline. There it is. Your control group provides a baseline, which allows researchers to measure the effect of active hives and empty hives and compare. It's not a placebo group. A placebo group is not a thing. Having no hives in a tree is not a placebo. It's just a no treatment. Okay, and then describe how the researchers could carry out the random assignment. So they would label the trees. Sorry, randomly, I'm missing something. Oh, there it is. Assign each tree an integer 1 to 72. Okay, and then we need to randomly generate 24 different numbers using a random number generator. the whoops, nope, we're not at the remaining yet. The trees with these labels will get the empty beehives. Okay, next randomly generate integers 1 to 72. Careful not to choose trees that have already been selected. These trees will get the active beehives and then the remaining. Then we measure the damage and then we compare. Maybe. So assign, randomly generate, treat, randomly generate again, treat, remaining, get that treatment, measure, and then compare. Okay. Many people start their day with a jolt of caffeine. We want to describe the statistical benefits of controlling subjects' diets. Oh, goodness, whoops. Okay, so the statistical benefit of controlling subjects' diets. So this reduces variability in the response variable performance on the tapping, makes it easier to determine the effect of caffeine withdrawal. So controlling helps reduce variability. How was blocking used in this experiment? What is the benefit of blocking? So each participant will take the caffeine tablets one of the 2 days and the placebo the other, and that helps account for individual differences in dexterity. Some people just might be better at tapping. So, all right, so it's not working. All right, how might confounding occur if the treatment order was not randomized? If all subjects got caffeine the second time, the researchers would not know if the increase was due to the practice of the tapping or because cause and effect. Explain how this is double blind. That's neither the subject or those interacting with them. No. All right, and then one last one. Okay, the counseling department at a large high school wants to estimate the proportion of last year's graduating class who are enrolled in a 4-year college or university. To do this, they hope to survey 50 of the 800 graduates from last year. Describe how to select a stratified random sample of 50. So we are looking at where individuals are going after they graduate. So it's giving us options, but if this were an upper Q, you would have to think through how could I stratify? So, I mean, I think yes, class rank is definitely one way. If it weren't class rank, like if you weren't given some things, I would think maybe like honors AP students versus non-honors AP students. As a strata, because the proportion of graduates who are enrolled in a 4-year college or university may differ according to those who were top half or graduating class. And then our process, so we are going to so we're not going to label 800 because we're stratifying. So label the 400 students, the top 400, 1 to 400, generate 25 random integers from 1 to 400 using a random number generator and select those students. Label the bottom 400 students, 401 to 800, generate 25 random integers from 401 to 800 using a random number generator, select those students. So that's what it would be, because we said we're stratifying by top half or bottom half, so we're cutting those in half. What's the impact and the advantage of using a stratified random sample? We are guaranteed 25 students from the top and bottom half, and that will lead to a more precise estimate. So When counselors send an email to 50 students selected for the sample, only 21 students respond. Explain how non-response could lead to bias and what the effect of bias will have on the estimated proportion of students who are enrolled in a four-year college or university. Non-response bias might lead in the study might because the people who are it's not the people who are not selected. The people who are not enrolled in a four-year college may be less likely to respond to this survey. So, and that's just because, I mean, maybe they just don't care. Versus someone who is enrolled might be excited to share, yeah, I'm going to this college. This will likely produce an estimated proportion that is too large because we would have more people saying yes, they're going to a college. So it's an overestimate, as the people who respond to the survey are probably more likely to be enrolled in a four-year college or university than those who did not respond. So I think I answered every question, and let's see how I did. Oh, I missed one. Sorry, you guys. I'll get back to you on what one I missed. Give me 1 second. So I missed this one because I didn't answer it. So I just left it blank. Apparently I think I boxed it, but I didn't answer it. So nope, that was all correct. Good luck on your guys' test tomorrow. Please email me and I will try to get back to you if you have any questions.